Hey everyone, this is Mr. Geisway, and these are your Section 1-1 notes. Today we're going to be comparing and ordering real numbers. So we're going to start off with the real number system. Basically everything in Algebra 1 is dealing with the real number system. You add some more stuff in Algebra 2. But the real number system is made up of two parts, and those are the rational and irrational numbers. So your rational numbers are the numbers that can be written as a fraction, like an integer over an integer, like 1/2, or even numbers like -5, because that could be like -5 over 1. And then your irrational numbers, these are numbers like square root of 2, just different numbers like that that cannot be written as a fraction. These are mostly square roots, decimals, also numbers like pi, that they don't end. If you write them as a decimal, they're not terminating, and they don't repeat. So your rational numbers, this is just like I said here, this can be expressed as the ratio of two numbers, or what we more commonly know as fractions, where the denominator cannot be 0. That's not allowed. In decimal form, like I just said a little bit ago, they either terminate, which means they end, or they repeat. So 5 over 8, if you enter that in your calculator, that will give you 0.625, which terminates. And then numbers like 1 over 9, this is just 0.111111, just the 1 repeats. So those are examples of rational numbers. Irrational numbers, as I said, these are numbers that cannot be expressed as the ratio of two numbers. They cannot be written as a fraction. And when we're talking about fractions, we're not saying like pi over 2. We're talking about integers, so like 5 over 2 or -6 over 7 or something like that. And here's an example. This does not terminate or repeat. 4.03004, 0005, 00006, something like that. It does not repeat. It does not end. It keeps going on and on. So we want to know, here we have 4 options, A, B, C, or D. This is a multiple choice question. Which set would include both rational and irrational numbers? So first of all, if we look at set A, these are all rational. These are all fractions. So A would be out. That is not, there are no irrational numbers in there, so that one is out. Part B, or option B, we have 0.6 repeating, so that is something that repeats, so that's rational. 0.25 terminates, that ends, so that is also rational. And then 0.1212, just going on and on and on and on forever, that's going to repeat, 1212. So that is, again, also rational. Down here for C, we have -1, -14, and 7. These are all integers, but integers can be written as a fraction. Okay, we can write -1 as a fraction. That would just be -1 over 1. -14 can be written as a fraction, like -14 over 1, or -28 over 2, or something like that. 7 is also a fraction. That could be 21 over 3, or 7 over 1. So C, those are all rational numbers as well, so that is out. Process of elimination, we know that it has to be D, but if we look at this, if you take your calculator and you enter the square root of 5, when you type that into your calculator, that's going to give you 2.236067978. That does not repeat, that does not terminate, so square root of 5 is irrational. And then moving right along here, square root of 6, if you enter that in your calculator, you're going to get 2.449489743. Again, that is irrational. And then the last one here, square root of 9, if you enter square root of 9 in your calculator, maybe you already know that the square root of 9 is equal to 3. So square root of 9 is 3, which is a rational number. Okay, because we can write that as a fraction. That's just 3 over 1. So the correct answer here would be D, square root of 5, square root of 6, and square root of 9. Okay, square root of 9 is your rational, square root of 5 and square root of 6 are irrational. Alright, next, we want to know, where does the square root of 3 fall on this number line? Alright, so again, what we want to do is we want to look at, what does the square root of 3 approximately equal? So if we look at that, the square root of 3, okay, if you enter square root of 3 in your calculator, let's just look at 3 decimal places. So the square root of 3, if we do that, that's going to end up giving us 1.732. Okay, so we want to know where on this number line does 1.732 approximately land? So if we look at this, we have 1 and then the end is 2. So each of these are 0.1. So this would be 1.1, 1.2, 1.3, 1.4. So W is out because that's a little bit after 1.4. Next would be 1.5, so X is out. 1.6, 1.7. So if we look at Y, that's a little bit past 1.7. So if we look at our answer here, 1.732, it looks like Y is going to be our best approximate answer, our best approximation, because this will be 1.8 and then 1.9. So Z would be something like 1.91 or something like that. Okay, so the closest approximation here would be Y. That would be about 1.732 or square root of 3. All right, next, when we are comparing and ordering real numbers, basically what we do is we change all of these to decimal form. Okay, it's so easy. It's way easier to compare numbers in decimal form than when they're written as fractions or square roots or mixed numbers or anything like that. So we always want to change them to decimal form first. And basically we're just going to do that with our calculator. Then we have 4 different ways of comparing our numbers. This symbol right here means is less than, so one number is less than another number. If we have the line underneath it, that means it's less than or equal to. This symbol right here is greater than, so like 10 is greater than 0 and is greater than or equal to. This could be something like 10 is greater than or equal to 10, or it could be something like 10 is greater than or equal to -4. Okay, so those are the 4 symbols that we will use to compare numbers. So let's move on to this. First of all, let's just get some practice with entering the numbers in our calculator to get the decimal. So if you know how to do that already, you can go ahead and do that. Enter those numbers in there and check to see if you did them correctly. So for C, what we will do for part C here is we're actually going to take the -1, and that just stays a -1. The 3/5 becomes our a decimal portion of this. Okay, so -1 is the whole number. 3/5 is your decimal. So you take your calculator, you go 3 divided by 5, and that's going to give you 6. Okay, so -1 and 3/5 as a decimal is just the same thing as 1.6, or -1.6 in this case. The next one, part D, is going to give you, again, we already have the negative there, so we can just recopy that negative sign down. All right, so this is just going to be a negative, and then the square root of 2 gives you, let's just cut it off to 4 or 5 decimal places. You can see this one is also irrational. It's not going to end. So 1.4142, 4142. Okay, somewhere in the area of 3 or 4 decimal places is what you want to stick with, just in case when we're comparing things, we want to make sure we have enough decimals there. And for E, pi, most of you could probably tell me that 3 is approximately 3.1. I'll try to squeeze the 1 in there. 3.14, but if we keep going, this will be 159 and blah, 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 blah. It keeps going on and on and on forever. Okay? So, just in case you can't read my handwriting, I will go through these, have them typed out here for you so you can copy them down. So, -1.6 is C. -1.4142 is D. And again, 3 or 4 decimal places is good there. So, -1.414 is okay. And then E, pi, 3.14. Again, we want to make sure that we're going more than just the 3.14. So, 3.14159 or 3.142, if you round it to 3, that 5 would bump the 1 up to a 2. But again, 3 or 4, so 3.1416, 3.142, any of those would be acceptable if we're estimating or rounding. Alright, so let's compare some. We want to know which of the following is true. Now, A is a very common problem that people tend to make mistakes on. Alright, and the reason is because they say 4/9, they enter that in their calculator. 4/9 gives you 0.4 and it repeats. So 0.4 repeating, and they say, well, that's the same thing as 0.4. Well, it's not. Let's add an extra digit here. Okay, so if we take this and we add one more digit, alright, let me erase this. If we add a digit, 4/9 would be 0.44. repeating, right? Whether we repeat the 4 or we repeat the 44, it doesn't matter, it's the same thing. So now we can see, is this the same thing as 0.4? If I add a digit here, it will be a 0. So if you have 44 cents or you have 40 cents, we can see that those are not the same anymore. So A is out. If we go on to B, if we enter this in our calculator, pi divided by 2, this will be approximately 1.5 because pi is about 3. So pi over 2, if you enter that, this will be 1.57 and then it's a 0. But that's enough to clearly tell that B is the correct answer because 1.57 is less than 2. So we know that B is the right answer. If we look at the rest of these, C, we have a negative number. Well, a negative number is never greater than a positive number, so that one right away we can get rid of that. And then for the last one, if we look at square root of 5, enter that in your calculator. The square root of 5, first of all, the left-hand side here, 2.51. We want to know, is this less than, square root of 5 is 2.236. Again, we can see that's false because 2.51 is greater than, not less than. So D would be false. Correct answer is B, but we want to just double check and make sure we did the other problems correct. All right. So there you go. B, correct answer. G. We want to know which of these lists shows the numbers below in order from least to greatest. All right. So the first thing that we want to do before we start to actually put these in order from least to greatest is we want to make sure that we change all of these to decimals first. Okay, so that will be our first goal, is we want to take this and we want to change all these to decimals. So the square root of 21, again, enter that in your calculator and you will get 4.58. Let's take it to 3 decimal places. So 5825, that's going to round that up to 3. Okay, the next one, 15 over 4, enter that in your calculator. You can basically just look at that as 15 divided by 4. Either way, that will give you 3.75. That ends there, that terminates there. There is no other numbers after that. And then 4.3 repeating. We don't need to do anything with that. It's already written as a decimal, so we are good there. All right, so if we are going from least to greatest, make sure you read that because sometimes it will say greatest to least. If you're going from least to greatest, we need to see which of these is the smallest. And we will put this back in the original form, so we're not going to put 4.583, we're not going to put 3.75, we'll go back to the original form. So the smallest number here, we can see is 3.75. So that means the first number has to be 15 over 4. Only one of our lists has 15 over 4 first, so we know the correct answer is D. But then next, 4.3 is smaller than 4.583, so we know 4.3 goes before the square root of 21. So our correct answer here is D. All right, so that's all the examples for today. Make sure that you are writing down all your notes. Show that to me in class.